My friends, what's happening, algebra people of the world? Here we are. It is lesson 8-2. Bam. Look, this is some easy stuff we got today. Can you guys all multiply? Because that's what we're about to do. So, 7th grade, we learned distributive property. Today, we're going to pretty much just do that. And it's really not bad. So we just have to be careful when we're, like today, the only difference, guys, we're going to see a variable in our term that we're going to distribute into this expression here. Okay, that's really the only thing new, I think. We're going to write a couple expressions using the distributive property, of course. And then we'll get to some really fun multiplication we call the FOIL method tomorrow or the next day. All right, anyway, here we go. So we're going to go ahead distribute this 6 into all three terms. Looks something like this. So we're going to get 24. Our y is actually going to turn into y to the third power. Again, you got to think back to all that fun stuff that we did in exponents, right? All of our exponents rule. This is going to be y squared, and this is going to be minus 42y. There you go. Typically, if these are in standard form here, when I multiply whatever I'm going to multiply through, it's still going to be in standard form. Okay, so good to go here, right? If you notice that this is in standard form, and then all of a sudden your answer isn't, double check your multiplication. You might have made a mistake distributing whatever term we needed to. Okay, so pretty straightforward there. Scroll on up here. Let's tackle this one real fast. Again, distribute 3x into all of these terms here. Again, only thing really to watch if this was a negative would be what those terms are going to turn into. But for the most part, guys, really no bear traps today, right? Just reminding ourselves, right, of distributing, reminding ourselves of when we have variables, right, other than, two different ones, and we're multiplying them together, what happens? Okay, this one, look, they're just giving us more work to do here, right? That's really all this is. So we're going to distribute first 6t squared minus 12t 45. This is going to turn into, again, watch your signs, t squared plus 12t. Okay. From here, hey, we can combine like terms just like we were doing before. So I've got 2 here, 1 there, 2 here, 1 there. Okay. So these are going to combine to 36t squared, right? Check that out. That cancels out, right? Negative 12, positive 12 goes away. Just left with 45. Sweet. Okay. Any questions yet? No? Okay. We'll keep going then. Same thing here, right? Distribute the 5. This will turn into 20. Y squared plus 25y minus 10. Great. Plus 8y squared plus 6y. Again, if you want to do the underline thing, you certainly can. Okay, those two got to go together. That's 28y squared plus, I think that's 31y minus 10. There you go. It's a good-looking trinomial, ain't it? Okay. Let's see. Yeah, so pretty straightforward here, gang. All right, hopefully you're enjoying this. Oh, boy. Oh, boy. Okay, then we get into this weird stuff here. So we need to write an expression for this scenario. The trick is we can only use one variable. If they would let us use 2, this wouldn't be that hard, okay? But we're only going to use one variable because at the end of the day, look, we're smart enough, we can figure this out. All right, admission to the super fun park is $10, okay? So everything that costs money, guys, I'm just going to, okay, so admission, $10. Got it. Once we're in the park, super rides, not sure what a super ride is, but I apparently would like to go on one, are $3 each because they sound better than a regular ride, which is $2. Okay, so recapping, $10 to get in. Apparently, if we're going to take a super ride, which I will, it's $3. You guys can all go on the regular rides that are an additional $2. Okay? Our friend goes to the park and rides 15 rides. Okay? 15. Of which S, so there's the variable they want me to use. So S of those 15 are super rides. Those are the $3 ones. Find the cost if Wyoming rode 9 super rides. Okay, so that's the second part of this. Okay, so we know we went on 15 rides, and they're saying use S. S of them were super rides. So what are the 3 things that cost me money, right? Well, I've highlighted them up here. Admission, super rides, regular rides, okay? So we need to write expressions for each one of those. So admission to the park is 10, right? That's going to kind of be like our constant here all the way down at the end of our expression, right? $10 to get in. Okay, super rides are $3. They want me to use S for super rides. So super rides is going to look like this. There's some amount of super rides we're going to go on, and I hate using S's because S's look like 5s. So really try to make your S's, curvy or something so that they don't look like 5s. Right? Again, however many of these, we multiply it by 3, that's how much money we're spending on super rides. Now, regular rides are $2, so it would be great to put plus 2R, and I think that's what a lot of us would like to do. However, we can't do that, okay? Because, look, at the end of the day, it says, hey, you rode 9 super rides. So how can we relate the number of regular rides that we go on if we know we went on 15, right? It says we ride 15 rides. Well, some amount of them are super rides. The rest of them would have to be regular rides, okay? So regular rides are $2. We're going to put a little something in here, right? This is where we're going to put, hey, you go on 15 rides, but you have to subtract out all of your super rides first, right? Because if you get rid of all the super rides you went on, then whatever number is left, we'll say, hey, that's how many regular rides you went on. Multiply that by 2, and that's how much money we spent on regular rides, okay? So here's super rides plus regular rides plus admission fee, and this equals like our total cost, how much money we spent, okay? So there's our expression there. Okay, so we're good there. Now we can find the cost if we went on 9 super rides, okay? So again, we will just substitute 9 in for S, and our expression will take care of everything else. I guess if we wanted to make it an equation, we could say, our cost equals this. That would be okay too, okay? So we'll say 3 times 9 plus 2, and you could simplify this if you would like to, right? Meaning like you could have distributed here, that would have been appropriate, okay? But we're going to get the same answer. So let's keep simplifying here. This is 27. We know this turns 15 minus 9, guys. What does that turn into? I believe the number 6. So this is going to turn into 12. That's going to turn into 10. Right? Add all these up. That's $39, $49. That seems like a lot of money. But you got 15 rides, I guess. So, Cool. All right. Anyway, so there we go. So, again, the trick here, writing it all with one variable. Okay? Again, this is something we'll get better at. This is going to be the same kind of scenario here. We're going to write this one. I don't think this one's as tough. We've got these Fosters. They own a vacation home that they rent throughout the year. Great. The rental rate during peak season, right? $120 a day. Rental rate during the off-peak season, okay, is obviously less money. It's $70 a day, okay? So again, those are the 2 different rates. So peak season money plus off-season money equals the total amount of money, right, that they earn every year from renting this house. Last year, they rented the house for 210 days. Okay, pretty good, 210 out of 365 days. P of which were during the peak season. So they're saying, hey, there's this many days during the peak season, which is that $120. Okay, then there's the rest of the days that are at the non-peak rate of $70 a day. Okay, so again, let's write for this. Okay, I need to move this up a little bit here. There we go. All right, so we know we are $120 a day for peak season, which they said we'll represent with P. Right, we are going to add that amount of like rental money to non-peak days, which are $70. Right. Here comes our distributive expression. Any guesses on what it's going to look like? Again, 210 days is how many we rented it for. Some amount were peak days, meaning the rest of them were non-peak days. So it's going to be that 210 minus P. Okay? And there we go, right? This is going to be equal, right, to how much money we've rented the house for in the course of the year. All right, so there's our expression, equation, whatever you want to call it, if you put an equal sign on it. And now we have to do this. So how much rent did they receive if P, so the number of peak days, is equal to 130? So that means I'm going to have to get out my brain calculator here. So we're going to substitute in 130. All right, this equals how much money we get. I really don't feel like doing this. Hold on real quick. Oh, look, got a calculator right here. Okay, 120. Whoa, get out of there. Yikers. 120 times 130, guys. That's $15,600. Good for them. Okay. This is going to turn into what, 80? Okay, so this turns into 80. I can do this one. 80 times 70. 5, 6, 2 zeros. All right, so total amount of money, we're just going to add those two up, and we get $21,200. There we go. Seems like a pretty sweet deal. Okay. All right, so there's that. Good news, guys. Good news. You ready for the good news? Your most favorite thing in the world. Come on back right here. Okay. So this looks a little bit like what we did to start the day, right? Distributing. And then they had to go and throw a little equal sign in here. So let's solve this equation. We're going to see some interesting things. We'll talk about them along the way. So distribute b. So this is going to turn into 12b plus b squared. Interesting, guys. I don't know that we've ever seen a second power, right, variable in an equation yet, my friends, minus 4b plus b squared. Okay? So we haven't seen these yet. Good news. This is what this chapter is all about. Okay? All right, if you think of your two sides, here you go. We got no numbers anywhere. This is really weird. Okay. All right. Sounds great. Let's go ahead and, oh no, we got a number here. I'm going, wait a second. Okay, so we got a little number here. So let's try to get all of our variables onto one side. Does that work for you folks? Because it works for me. All right, so first thing I'm going to do is let's move b squared over here. So we're going to subtract b squared. Ooh. We don't have to deal with this today, thankfully. All right, these go away. All right, so my b squareds cancel out. I'm left with 12b minus 7 equals, let's go ahead and combine these. 2b minus 4b would be negative 2b. Okay? We're going to move 12b over here now. Obviously, a little bit of subtraction will do that for us. Negative 7 equals, again, we're subtracting 12. I'm going to say negative 14b. Okay? Divide by your coefficient. Okay, so we'll divide here, and not bad. B equals positive 1/2. Good to go. All right. So again, things to note, right? We had b squared, right? So we had a variable to the second power. Luckily, that went away. I was a little worried there for a sec. If you guys want to try this one, you can. My goodness. Could they be any more annoying here? All right. So look, this is not a big deal. Distribute. Combine whatever terms we can on the left side and the right side. And then, we'll move variables to one side and we'll see what we get. Okay? So x squared plus 2x plus 2x squared minus 6x plus 7. There's a lot of stuff going on there. Okay? Let's distribute all this. 3x squared minus 15x minus 12. So really nothing to combine there. We can combine these, right? Sorry, 2. We can combine those. So 3x squared minus 4x plus 7. All right, now we're home free, guys. Well, we're not really home free yet, but we're about to be, okay? To be different, let's move x's to the left, numbers to the right, okay? So first things first, we'll move this, right? We'll subtract this from both sides. Good news, right? It cancels out again. Eventually, guys, they're not going to cancel out, and we're going to have to deal, all right, with those. And I lied. I mean, I love me some exponential equations, but these are pretty fun too, okay? All right, so we're going to go ahead and we're going to add 15x over here. So we're going to add 15x. Let's see, this should turn into 11x. We're going to go ahead and subtract 7 over here, if you guys are okay with that. So we're going to subtract 7, and this is going to turn into negative 19. And then go ahead and solve it. So not a great number here, but that's okay. So x is equal to negative 19 over 11. Perfectly fine if we leave that number like that. That's a simplified improper fraction there. No reason to change that to a decimal or a mixed number. Okay. So good to go. Guys, so there's A2. So really nothing too terribly bad. The writing part of writing those expressions with one variable, okay, take your time, figure out what your different quantities are, and then write expressions for them. Have a great day. See you guys later.